Chapter 18, Think and Explain. So number 48, air is quickly compressed. Why does the temperature increase? So basically you've got a gas and you're compressing it, you're putting it into a smaller volume, you're adding pressure, and as you're putting energy into the system, you're basically doing work. You're forcing molecules in the direction that they are being forced. If you're doing work to a system, you're putting energy into the system. That energy has to show up somewhere, and it generally shows up as an increase in temperature. 49, if you do 100 joules of work on a compressed gas, again, this is still Newton's, or not, first law of thermodynamics. You put energy in, you get energy out. So as you put energy into the system, you put 100 joules into the system, that's the work done in compressing a gas. 80 escapes, and you're left with 20. So the change in internal temperature is 20 joules. What happens to the gas pressure in a sealed gallon when it's heated? So there's basically two ways to change pressure. One, add more molecules bouncing against the surface, or make them go faster. And so by increasing when it's heated, using everyday vernacular, you are changing the temperature. So increasing the temperature means you're increasing the speed of the particles. They're banging against the walls faster. You're going to increase the pressure. When it's cooled, you're decreasing the pressure. And if you decrease the pressure inside fast enough, you basically, the air pressure will come in, collapse it. And Bill Nye's got a great demonstration, I think, where he's using a big metal tub or metal barrel to do this, and he crushes the metal barrel by heating it up and then turning it upside down into cold water. This the quick loss of pressure, the air crushes it. 61, you cool a kitchen could you cool kitchen by leaving the refrigerator door open and closing the door and windows? So the refrigerator basically is doing work on what's inside. It's basically cooling the air inside a refrigerator, and that has to go somewhere. They're pulling it out of the internal contents of the refrigerator, and it basically puts it into either coils on the bottom or coils on the back of the refrigerator, which then air goes through, cools, and takes that heat away. So if you open the refrigerator, basically that heat that goes off is eventually going to come back into the refrigerator. You are basically expanding your closed system, and so there would be ultimately no temperature gain, but what it would end up happening is you would end up heating up what's inside the refrigerator. Anyone who's accidentally left the refrigerator door open overnight knows what's going to happen there. 65, refrigerator moves from heat from cold to warm, opposite of what the second law of thermodynamics says. Why is this not a violation? Under natural processes, it will do this in order to actually get things to move into a ordered system. It takes work from a physics point of view. And so you can expend energy in order to do that, just like cleaning a room. Things naturally have a tendency towards disorder, but you can change that by actually putting work into the system by moving things, and so it doesn't violate it because you have an external source. 71, total energy of the universe becomes more unavailable with time, or does it? Yes, because hot things cool down, cool things will heat up. Eventually we're all reaching that same level temperature, which we talked about in class, sort of heat death. And so the more everything becomes the same, the less temperature difference there is. That means there's a smaller energy difference between things, so it's very hard to pull. You're basically losing energy to pull things out of. 74, ocean possesses an enormous number of molecules, all with kinetic energy. Can energy be extracted? Yeah, you can, but you won't gain anything by that. It's much better if you're going to pull things out sort of as they're naturally going, such as putting a turbine under a waterfall to get something to spin there. You're using that energy that's naturally there, but ocean is already basically at sea level. So in order to extract energy, you have to look, if you pump water out and then put it down across a turbine, that you're basically going to spend more energy than you're going to get out of it. Potentially you could get it off of thermal currents within the water themselves, the thermal currents, that you have a hot section of water and a cold section of water and temperature will flow. Potentially you could use something there, but I suspect it's not particularly going to be not really efficient or worth the expenditure. And then chicken develops from an egg, becomes more ordered with time. Does it violate? No, because the chicken, the hen is using energy in order to create the egg So any energy that goes in and creating the order, the hen will lose, and so the hen can get it back by eating food and exercise. Eating food basically gives the energy back to the hen, which allows it to then use that energy in order to produce the egg. So it goes against entropy, but it doesn't violate the principle of entropy, because we're not dealing with just an isolated system with nothing else going on. So that's it for the Think and Explain.